Welcome. In this video we'll be graphing trigonometric functions. Sine part 1. Use a graph of the parent function shown below to sketch the stated function using radians. Also find the amplitude and the period of the function. The function we want to graph is y equals 4 times sine of theta. However, in order for us to do that, let's analyze some key characteristics of the parent function, which in this case happens to be y equals sine of theta. Now, notice a few things. First of all, the zeros occur at 0, pi, 2 pi, and 3 pi, given the window for us. That is, the zeros occur at multiples of pi, in particular at integer multiples of pi. That is, at n times pi, where n could be either 0 or any of the integers, plus or minus 1, plus or minus 2, and so forth. Also, notice that the maximum is 1, and that happens at pi over 2 or any 2 pi units after that. That is because the period of sine happens to be 2 pi radians. In addition, the minimum is -1, and in this case it happens at 3 pi over 2 or any 2 pi radians after or before that. So we can say that sine of theta is always going to be bounded by the following two numbers, -1 and 1. In addition, based on the graph, we can extract the following information and generate a table of values. So we can say, well, let's pull out some of the key values between 0 and 2 pi for theta. So we have theta could be 0, pi over 2, pi, 3 pi over 2, and 2 pi. Then we can talk about the output values, the y equals sine of theta. So for theta being 0, we have that y is equal to sine of 0. For theta is equal to pi over 2, we have that y is equal to sine of pi over 2. Then for theta is equal to pi, we have y is equal to sine of pi. And then we can extend this table and say we have y is equal to sine of 3 pi over 2. And y is equal to sine of 2 pi. Now let's go ahead and get the values, or let's extract the values out of the graph, given the parent function graph. So we know that for theta equals 0, the output happens to be 0. So sine of 0 is 0. Then for pi over 2, the output value is 1. So sine of pi over 2 is 1. Then for pi equals, or theta equals pi, the output value is 0. So we have that sine of pi is 0. Then for theta being 3 pi over 2, we get that the output happens to be -1. So we have that sine of 3 pi over 2 is -1. And lastly, for an input or theta of 2 pi, we get that the sine or the output value is 0. Now, we're going to extend this particular table, and we're going to now include y equals 4 times sine of theta, because that's the function we want to graph. So we can say, well, we have y is equal to 4 times sine of 0, for theta being 0. Then we have y is equal to 4 times sine of pi over 2, for theta equals pi over 2. Then we have y equals 4 times sine of pi. Y equals 4 times sine of 3 pi over 2. And y equals 4 times sine of 2 pi. And let's go ahead and evaluate these expressions here, these middle expressions, and see what are the actual values. So sine of 0 we said was 0, so you have 4 times 0 is 0. Then you have sine of pi over 2 is 1, so you have sine of pi over 2 is 1 times 4, it gives you 4. Then you have that sine of pi is 0, so you have 0 times 4 is 0. And sine of 3 pi over 2 is -1. -1 times 4 gives you -4. Sine of 2 pi is 0. 0 times 4 gives you 0. So let's go ahead and plot this particular values. So for theta being 0, we get an output of 0. For theta being pi, we get an output of 0. And for theta being 2 pi, we get an output of 0 for y equals 4 times sine of theta. However, when we have pi over 2, the output is 4. So let's go ahead and get that point plotted. So we have the point pi over 2 comma 4. And then at 3 pi over 2, we have the point at 3 pi over 2 comma negative 4. So we just connect this few points and create our quick sketch here. And we get that this represents the graph for y equals 4 times sine of theta. Now the next thing we need to do is to figure out what is the amplitude. And the amplitude, if you guys remember, well, it's simply the distance from the midline to the maximum point, okay, or the maximum value. In this case, that distance happens to be 4, or it can also be interpreted as the distance from that midline to the minimum value. Okay, so that distance is still 4. Another way to figure out what is the amplitude is to take the absolute value of the coefficient of your sine. So notice here, the coefficient of sine happens to be 4. So we take the absolute value of 4, which is 4, and that is our amplitude here for y equals 4 times the sine of theta. In terms of the period, what we need to do is to say, well, we take the period of the parent function, which we said was 2 pi. So we said that the period will be the 2 pi divided by the absolute value of the coefficient of theta. Okay, and here we have an implicit 1. So we take the absolute value of 1, and we get that this is 2 pi divided by 1, which is 2 pi. So the period of y equals 4 times the sine of theta happens to be 2 pi. And this concludes this particular video on graphing trigonometric functions, sine part 1. Thank you for watching, and have a wonderful day.